I can find the constant of proportionality and write the equation of a proportional line. Okay? So these are our keywords for today. Constant of proportionality and write the equation. All right? Now, this that later. All right, so write this for, or just hang out with me for a second. In 1870, the French writer Jules Verne published 20,000 Leagues Under the Sea, one of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. Okay? So here's a table. Copy this for me. I want to write it with you. And 1 league, okay, was equal to 3 miles. Copy this table for me. Now what if I have 2 leagues? What is that equal to? Okay? How would I know? Well, for 1 league was 3, 2 league is 6. What if I did 3 leagues? Now I have 9. What if I mixed it up on you, though? All right? What if I mix it up on you? I said, hey, I want to know 6 leagues. Could you figure that out? Did anybody say 18? What if I did the reverse? And I said, hey, all of a sudden I have 36 miles. How many leagues would that be? 12. How did I get that? Well, look, I just did 36 divided by 3, which equaled to 12. How did I get 18? I just did 6 times 3. Now let's talk about the story. 20,000 leagues under the sea. So I got 20,000 now. So I got 20,000 leagues. How can I change that to miles? What would I do? I would do 20,000 times 30, which would equal 60,000. Okay, so that's how my table could look. All right? Now, as I look at the next screen with me, what do you notice about the ratios that I created from the table? So the first ratio that we had was 3 to 1. The second ratio, so what do you notice about the ratios that I created from the table? Here are 4 of the ratios. The first one's 3 to 1. The second one was 6 to 2. The third one was 36 to 20. Also, these are all miles on top, leagues on bottom. Okay? Miles on top, leagues on bottom. Miles on top, leagues on bottom. Same thing, okay? So what do I notice? I notice that in my table we put miles on top of leagues, or one way to think about this, we'll talk about this later, but y over x. Now, why do we put y over x? Why do we put y over x? Well, let's take a look at the next page. A couple vocab words here for us. Down for me. Proportional relationship and constant of proportionality. Those are the words from the objective that we said were a little bit confusing, but we'll figure it out. And I think once we figure out here, once I add some context to this and explain it to you guys, it won't be too bad at all. Okay, so a proportional relationship. Copy this definition for me. A proportional relationship is a relationship, copy this, between 2 quantities, okay, 2 different measurements, okay, where the ratio is constant. Okay? So it's a relationship between 2 quantities where the ratio is constant, or another word for constant is just the same. Okay? And the constant of proportionality is just this equation. Okay, write this for me. Y equals K over X. Now, if I look back at the one that we just did, okay, we talked about the Y and the X. So the Y and the X would just be our miles over our leagues there. Okay? Now, how do I find K? That's what I just said, guys. K is we put Y over X. Okay, if you want to get real mathy for a second, how did I solve that? Okay, how did I solve that? I wanted to find K. So if I go back to my equation here, how do I figure out what K is? How would I do it? Well, if we go back to our one-step equations from before, we would just divide X by both sides. This is real mathy. If you don't get it, that's fine. But watch what happens then. These cancel out, right? So K equals y over x. This is supposed to be an x here, guys. Sorry about that. Y over x. That's how I find k. Okay, once again, confusing, I'm with you. But let's just do some examples and it'll make more sense. Okay, let's talk about this for a second. Megan earns $12 per hour in her part-time job. Show that the relationship is proportional. So how can I show that? Well, for the first thing is I have hours over the money, right? Over how much she earns. Well, she works 1 hour. How much money does she earn? She earns $12. She works 2 hours. She gets paid $24. She works 3 hours, 36, right? Each one of those would be my relationship there. Now, how can I write the equation? Well, the first thing I need to do is know that, all right, y is going to stay the same. X stays the same. Now I just got to figure out that k value, which remember we said was just y over x. If I look at my table here, okay, the money, just like in the alphabet, y and x. X comes first, then comes y. So how would I find this k value? I would just take 12 and put it over the x, which is 1. Or I could pick this one here, and I would put 24 over 2. Or I could pick this one and put 36 over 3. Which when I do that, they all simplify to what? 12 over 1 simplifies to 12, 24 over 2 simplifies to 12, 36 over 3 simplifies to 12. So what's my value? $12x. Or 12 over 1x, right? That's where I started. Y over x, 12 over 1. And there's my equation. Now we would probably simplify that like I wrote to start with, and just put it like that. Either one of those answers would work for me. Okay? Let's try another one. Here we go. All right, here's our table. We're going to show the weight of an object on the moon versus its weight on the earth. Okay? So here's our earth weight on the top. Well, remember, we talked about that being our x value. Our moon weight, we talked about that as being our y value. Okay? So roughly about something that weighs 6 pounds on Earth is going to weigh 1 pound on the moon. Something that weighs 12 pounds on the Earth is going to weigh 2 pounds. And you can probably guess the next one. If it weighs 18 pounds, it's probably going to weigh 3 pounds on the moon. Now remember, when I go to do my equation here, my k is y over x. So pick any one you want. If possible, I'll pick this one because this one's the easiest one to simplify. Okay, so what would that look like? Well, I know y needs to go on top, so I got 1 over 6. If I did the second one here, it would be 2 over 12. But when I go to simplify, it is just 1 over 6, which is the same thing, which is what I want. So now if I read the part below, x represents the weight on Earth, y represents the weight on the moon. So y, my weight on the moon, equals, what was my ratio? My ratio was 1 over 6. And then my weight on the Earth is my x. And there's our equation for that table. Okay? And it would equal 2. Okay? I think we're getting a little better at this. I think I haven't done a great job so far today teaching you, but I think by showing some more examples, we'll get there. Okay, just read through this with me. Every year, Gabriel's entire family gets together for a family reunion. This year, Gabriel's parents are hosting, and they have to cook a lot of food to feed the crowd. Gabriel has volunteered to do the most tedious job, shelling the peas. All right? There's a proportional relationship, so it's telling us that it's proportional between the amount of time minutes, look, there's our x, and the amount of time he spends shelling the peas, which is our x, and the weight in pounds for y. What's our constant of proportionality? Okay, so remember, constant of proportionality means I'm going to put the y over the x, which is another way of saying, hey, what's k, right? Now, how do I figure that out? Watch, guys, it's really simple. You ready? I'm going to use this first term right here. What was my y value? My y is 5. What's my x value? 10. Now, when I go to plug my answer in, when I solve this, okay, on my Excel, which we're going to do in a little bit, we need to simplify that. So 5 over 10 simplified, 1/2. That goes in our box. So what that means is that he's going to do 1/2 pounds of peas per minute. And notice how that's row, right? It's row pounds, which we started here. This is our pounds per minute. And there we have our answer. Okay? All right, let's try another one. Here we go. All right. Sadie's excited because her grandfather in New Orleans is going to teach her how to make pralines. Okay, there's a proportional relationship in the amount of pecans that her grandfather uses and the number of pralines that he makes. What's our constant of proportionality again? Remember, y over x equals our k. All right, so once again, I can pick this one right here. All right, you can pick any one you want. You know what? Let's pick a different one. Let's not use the top one. Let's use the bottom one. If it's proportional, it doesn't matter which one you use. So let's use this bottom one. Okay, my y value is 20. My x value is 4. Now let's go ahead and simplify. 20 over 4. Well, I know that 4 goes into both numbers, so 20 divided by 4 equals 5. 4 into 4 equals 1, or I could just simplify and make it 5. And there is our constant of proportionality. Okay? Now let's take it one more step, and we're going to write the equation, which is going to be really, really simple, okay? Now, we're going to write the equation, okay? So, same thing. We're going to start with, this goes back to our equation that we talked about a few minutes ago, okay, times x. Now, y is here. Y is just dollars. X is just our hours. So those can be any values that I want, right? I could figure out, hey, for 5.5 hours, it's going to be what? For 10 hours, it's going to be how much money she makes babysitting. So the only thing that's really going to change is this k value right here. Once again, how do I find k? K equals y over x. Okay, pick any term that you want. Let's go with the middle one this time. Kind of see a pattern. They're not always the same number, but they are in these couple examples that I pulled. Okay, so my y value is $10 over how many hours would she work to make that? 2 hours. And when I simplify, that equals 5. So when I go to type in my equation down here, it would be y equals, all right, put my k value next, that's what I'm looking for, which we simplified to make it 5x. So my equation would be y equals 5x, and that's what I would plug into my box down there. Okay? One more example, and then we'll do a couple together when we come back together here, okay? So let's look at this now, because this is going to figure it out. Okay, Adam is crocheting a scarf as a birthday present for her sister. She started this scarf yesterday and needs to finish it before her party. Okay, the table shows the relationship. What word am I missing so far? Okay, I'm missing a proportional word. It's not in here. So what do I need to do? I need to figure out first if they have a proportional relationship. Now, how can I figure that out? You may need a calculator to do this. But remember, I'm asking about that k value, which k equals, all right, y over x. Let's take a couple of these terms and figure it out. And remember, so far, if I go all the way back to my definition, okay, right, oops, too far, there, it has to be constant. They have to be the same. They have to be the same. So in this instance, what we need to figure out first is, are they the same? Is the relationship the same? So I'm going to start with this first one right here, okay? So I'm going to take 26 and put it over 25. And let's simplify and see what that equals. 26 divided by 25 equals 1.04. Now, for this to be proportional, I need each one of these to be the same. I'm going to pick the second one now. Let's find the second one. So if I do the second one, that's going to be the same thing. Y, 35, over x, which is 50. Are they the same? Let's check it out. 35 divided by 50. And that answer is 0.7. Are those two the same number? No, right? $4, 70 cents, 0.7. So this one would be no. And when you go to IXL in a second, that's it. Had it been yes, it would ask us to write the equation. Okay? All right. Hopefully that wasn't too bad. We're going to come back together and talk about a couple together after this video. So go ahead and watch it and then get ready and we'll do some practice together. Okay? All right. We'll talk to you guys in a few minutes. See ya.